Okay, so let's start to work on the challenge problem for chapter 15. Now the first problem. So we have a right circular cone. Okay, let's draw a cone here. If it is right, means from the vertices V, it landing the height is just the center of the circle. Normally we always cut the solid shape and see the cutting face. Okay, it's easy for us to see. Yeah, this cutting face is a triangle, right? So you can see we have a radius of the 6 and height of the 6. Then the sphere with the center V is tangent to the base. So if it's tangent to the base, right? So it must be like this, right? So and intersect tangent to the base of the cone. What is the radius of the sphere? So if we tangent the radius is equal to 6. Let x be a point of the S meet the curved surface of the C. So curved surface of the C here is the x. So if we cutting from the top, right, along the center axis of the cone, then we have this isosceles triangle, and the center here is a 6 and 6, so this 6 root 2, and we draw a circle here, right? So this length is the 6, and this length will be the 6 root 2 minus 1, and so this is the x, this is the y, right? So it asks us what's the x to the axis of the cone. So what is xy, right? So there is a similar triangle here. Okay, so this triangle is similar to this triangle. Okay, so you can see the xy over the length of this is 6, right, is equal to the 6 over 6 root 2. Then we can see the xy is equal to the 3 root 2. Okay, then the C is to show the intersection of the S and the curved surface. So by symmetry, you can see this is this point to any point on this point and this point and any point on the cone is a symmetry, right? It's the same height. So that's why this is the radius. So that's why you can see the intersection is a circle with the center of the y, right? And the radius is 3 root 2. Then the d is simple, right? Pi times the 3 root 2 square is 18 square. I mean 18 pi. Next. So we have a cylinder inscribed in the right regular hexagon. Okay, hexagon prism. So hexagon prism is with the top face of the hexagon, right? And with the here if we have a cylinder, right? That is the tangent to all the 6 sides, okay, of the base. So it's tangent to all the 6 sides, right? So we can see if the cylinder, the center is the O, right? And let's see the size is a 1, right? So let's see the height is h. So let's solve the hexagon prism. Okay, hexagon prism will be, we have the 6 of the equilateral triangles, so the 6 root 3 over 4 times the 1 square, then it's times the height. Then the v of the cylinder, v of the cylinder will be the pi times the this is 1, right? So this is the root 3 over 2. So it's the root 3 over 2 of the square. That's the radius times the height of the h. So the ratio of the cylinder over the ratio of the hexagon prism is equal to the 3, 4 over pi times pi over the 4 root 3 times 6. So then we have this one, and this one, root 3. So it's root 3 pi over 6. So next, so we have a scoop of the ice, and the scoop is tangent to each line, right? So now we can, let's cut it. Okay, let's cut it through the center. Okay, then you can see once you're cutting it, the cone becomes the cone become a triangle. Okay, and then the sphere become a circle. Okay, so this is the center of the circle. Then you can see the scoop is tangent to tangent to each line containing the slant height of the cone, right? So here is the tangent line. From the tangent line, we know here is the circle, right? This is the circle. So you know from the center to the touch point is 90 degrees. Okay, and now we know this one is 2, and the radius here is root 3. Now we know it's 1, so this is the 60, 30, 90 triangles, and so we know it is this is the 30, so this is the 60, right? So this is also another, here is another 30, 60, 90 triangles. So that's why we know this is the root 3, so this is the 3, right? Okay, so in this case, we are able to solve the volume of the cone. The volume of the cone is 1/3, and pi times the root 3 of the square times the 3, so we have the 3 pi. And the volume of the of our scoop is 4 pi over 3 times the r square, so it's 2, I mean r cube is 2 cube, right? So it's 3 is 32 pi. Then the eating, right, we eat is the v scoop. V eat is the v scoop minus the v cone. Okay, then after calculation, you will get the 23 over 3 pi. Next is okay, so it's the folding issues, the folding things, right? It's Detectagon. The Detectagon, the dodecahedron has 12 faces. Okay, so have 12 equal faces. Here is the 6th face, right? Here is the another 6th face. Okay, so let's see how many points are together. Okay, so this point and this point will be together, right? Let me change color. Then this point and this point will be together, right? And this point and this point will be together, right? And this point and this point will be together, right? So what we want to see, how fast we can go from the B to the A, right? Okay, so if you're evaluating, you can see here is the D1 and the D2, and so we can go from the B to D1, right? And D1, D2 is the same thing, right? So D2, then here is the E2, right? And also then we can go to E2, then we can go to the A, right? So we do 1, 2, 3, right? So that's the 3 steps. Okay, so for this one, for the folding things, you need to find the corresponding points. Once you find the corresponding points, then it's easy to see. So next is two parallel planes intersect the sphere. Okay, so think about the two parallel planes. It's cutting the sphere, right? And it's parallel. So once you cut, let me explain a little bit. Okay, so here is a one plane, and here is another plane. Okay, they are parallel. Okay, this is called P1 and P2. Once they are parallel, so you can, once you're cutting through the cutting, there is a circle, right? So there is a diameter. If you're cutting through the center of the diameter from the top to the bottom, right? Then like you cutting like this, okay? Then what you can see, there will be a circle, right? Then this plane, the intersect point will be its diameter, right? Will be the circle diameter here. Then the other one will also be the circle diameter here, right? So we have the congruent circles, means the radius, the diameter is the same, or the radius is the same. Let's say D1 and D2, right? So two diameters. This is the cutting face. Then what we have is the D1 equals D2, right? Then we want to prove the we want to prove the midpoint between the segment, right? So we want to prove the midpoint between the segment is the diameter. Okay, we know the D1 equals D2, and the D1 also parallel to D2, right? Two faces the same, so that's why the diameter is also parallel. Then we can take the center of this, right? So we know that if they are equal over a circle, right? This must be a rectangle. Okay, so now let's do this. So even we don't use the rectangle case, okay, we know the chord is D1, this chord is D2, right? The same chord span the same arc. Okay, so we see the ARC1 is equal to the arc2, right? So ARC1 equals to ARC2 means the two of the angle is the same. For example, this is the 2 theta, then this is also the 2 theta, then this is the 2 theta, then this is the 2 theta, right? So now you can see, okay, you can see because it's 2 theta, that means this triangle, right, is congruent to this triangle, right? Because they are parallel, that's why the two triangles are congruent. Okay, if the two triangles congruent, the height must be the same, right? The corresponding height is the same thing. So that's why you can see, okay, this h1 equals h2, and h1 plus h2 is the distance TNCE between D1 and D2, right? So that's why you can also see M is the midpoint. Okay. Next, plane P1 and P2 are perpendicular, and their intersection is a line M. Okay, so let's draw a plane. So we have a plane of the P1 and P2. So we have a plane of P1 and P2, then the line segment is the M, right? And place the P1 is 4 units from the point O. Okay, so let's see, this is the point O. Okay, this is the point O, then this is the 4 units, and the P2 is 6 units, right? So let's see, this is the A and this is the B. And the sphere with the radius of the 9, right? So sphere with the radius of the 9 is like this. Okay. So here you to the center is the 9, right? 6 plus 3. This is the center. So if the sphere meets the M at 2 points, X and Y, right? A and B, you find the AB. Okay, the first is what you need to know is the sphere is cutting by the P1 is cutting into a circle. Okay, so let me draw this one here. Okay, so here is the A, and let's see, this cutting point is first, see it's M and N. Okay, so we have the M and N, and here is the sphere center, right? And then we know here is a 4. Okay, and the radius is the 9, right? So here is your cutting point is like it's like a circle, so that's why we can solve the radius, right? So the radius R is R1 is equal to the 81 minus 16, so it's root 65. Okay, now we know this is R1, this is C1, right? The C1 and the M is on the same plane, right? Let's draw C1 first. So here is the A. So here is the A, and the A to the end here circle is root 65. Then root 65 and the A to the M. Okay, A to the M is 6 units, right? So it's root 36. So you can see the A is inside, the A to the M is the distance inside here, right? So here is the 6. Here is the root 65 minus 6. Okay, then here we have the intersect of the A and the B, right? We want to calculate the AB, and this is the M, right? So now you can see we have the Pythagorean theorem, right? So this is root 65, and we want to calculate it, and we know this is 6. So now the AB will be the 2 times of the 65 minus the 36. So the AB will be the 2 times the 9 and 29. Okay, so this is the AB. So the next is X is on the circumference of one base of a cylinder. Okay, so let's draw it. So we have a cylinder, and the X is on the one circumference of the cylinder, and the Y is on the other base, such as X, Y bisect by the axis. Okay, so you can see if along with the axis, so you must be the somewhere, this is the center axis, right? You bisected the axis, you must intersect with this axis. So you can see here is the it's a no matter how, it's always a rectangle, right? And you want to bisect this one. So this is a rectangle. Then we know the center is the height. So that's, if you want to bisect this one, it must be the diagonal, right? You can using this one equal this one. It's 90 degrees. So these two triangles are this triangle will be congruent to this triangle for the right triangles. then you can this one equal this one equal this one. Okay, then given that the diameter of the cylinder is 8, so this is the 4 and the 4, and the xy is 12, right? So is 4 and 4. So what's the volume of the cylinder? So we want to calculate the height, right? So the height is the 144 minus the 8. 8 is 64. So it is the root of the of the 80, right? So now it's the root of 80. You can see it's 16 times the 5, so it's 4 root 5. Then you can see the volume will be the pi times the 4 square times the 4 root 5 will be the 64 root 5, then times pi. Next, so we know the end is on the outside of the cylinder glass and halfway up to the glass. Okay, so there is a cylinder glass. Okay, and there is a halfway up to the cylinder glass is M. Then the glass is 8 inches tall, so here is 4 and 4, and the radius of the radius of the 2 inches. Then these ends are not want to work to the points on the inside of the glass. So this is outside. Okay, so this is the all out. He wants to climb to the inside of the glass that is diametrically opposite to the point of the null. Okay, so it's diametrically here, so that's why but it's inside. Okay, so you can see from outside to the inside, you must climb then to the it's glass, right? You must go inside, then around the surface go here. So to find the shortest surface, that means we always have the shortest distance must be the line connected with the 2 points. But here is the line connected with the 2 points. Inside is empty. There's not a path. You have to go around the surface. Then in this way, we have to expand the surface first. Okay, so we can see if we expanding the surface, right, is a rectangle. So here is the M, right? M to the end, the other side is the M prime. So the N is on the opposite side. So N is in the middle, right? So now let's see so this is the pi. It's 2 pi r, right? So this is the pi r, and this is the pi r. Okay, now we have this one is 2, right? So we want to climb into that, right? So that means we need to along the surface. That means the shortest path, we always do the symmetry here. Means we need to climb on the surface somehow, then flip into inside, right? Then to here. So that means we need to find a point. That means this one plus this one is smallest. So we can do a symmetry point here. So it's M1, this is the 2, right? Once you connected this one, then this is the shortest. Why? Because this one by symmetry, right? This equal this, so this one will equal this one, right? So the D1 plus is equal to D1 here. This is the D2. So the D1 plus D2, the shortest is the line M1 and N together. So now you can see you have 2 pi here and you have 4 here. By Pythagorean theorem, you have the M1N equals to the 4 is 16 plus the 4 pi square. So now you can do take out the 2 is 4 plus the pi square. Okay. So we have a spiral stairs, and with the radius 3 feet, and turn the 270 degrees as it rise of the 10 feet. Okay, so here is the stair is like a cylinder. Okay, then we're starting from here. We go around here, right? And then we go here. Okay, then we turn around to here. So we turn the wave from here to 180 degrees, then to here, right? So this is the 270 degrees. So that means when we expand the surface, okay, when we expand its surface, it's like this. It's like a rectangle, and if we set this point is A, right? So this point is A, then this point is B. So the A will be here, and the B will be here. Okay, and we are doing a quarter circle, right? So that means this one is 4/3 of the circumference. Okay, curved all along the entire. Yeah, so this is always the, because this the no matter whatever the point, right? Whichever the point here, it's always the 3 feet from the 3 feet from the 3 feet from the center axis. Okay, 3 feet from center axis. This just means okay, just means the circle, the base of the circle have the radius of the 3. Okay, now we can calculate this, right? It's 4/3 of the 2 pi times the 3. This is this line. Then we want to see how long this curve is, right? After your expansion, the A and the C becomes the line, right? So now you can see for the Pythagorean theorem, we can solve this one is 9 pi over 2, right? And also the height is the 10 feet. This is the 10, right? So now you can calculate the AC. The AC is equal to the 81 pi square over 4 plus the 100. So a right circular cylinder with the diameter equals to its height is inscribed in a right circular cone. Okay, so now let's see. So a right circular cylinder. Okay, let's cut in the cutting the surface. Okay, so the cutting surface is like a regular it's a rectangle. Then this is the center of the cylinder with the diameter equals to its height. So let's see the diameter is 2x, the height is also 2x. Then the cone is inscribed in the cone. So here means that here is the cone. Its cutting surface will be a triangle. Okay, so this is the isosceles triangle inscribed with the the rectangle is inscribed in this isosceles triangle. Then we have ABC, ABC. Okay, then we know the cone has a diameter of the 10. So if the cone has a diameter of the 10, so the radius is 5. So we know it's the 5 minus x. Okay, and the altitude of the 12. So this has the altitude of the 12. Okay, so how to solve this is we still to use the similar triangles. Okay, so what we can see is the 5x and the 2x, right? So this this triangle, okay, is similar to this big triangle. Okay, so now you know the 5 minus x over the 2x is equal to 5 over 12, right? Okay, now let's solve this. So this one is the 5 minus x over x is equal to 5 over 6. Then 30 minus 6x is equal to 5x. Now x is equal to the 30 over 11. Okay. Next is the PQRS is a regular tetrahedron. Okay. The regular tetrahedron means we have 4 faces and every face is equilateral triangles. The distance from midpoint of P, Q, R, S, midpoint of the PQ to midpoint of the RS is 6 units. So this is the M and this is the N. So normally we always connecting this, okay? Because M is the midpoint, N is the midpoint, and so we can calculate in the Rn, right? This one is 6, so Mn is 6, right? So let's assume the side is A. Okay, once we solve the side, we can solve everything. So once the side is A, so this is the root 3 over 2A, right? And this will be the A, and this will be root 3 over 2A. Now we have a triangle of the N, RS, then this is the M, and this is the A over 2, right? So this is the root 3 over 2A, then this is 6. Now you can solve Pythagorean, right? Still Pythagorean. So 4, 3a squared minus the 1 over 4a squared is equal to the 36. Then you can see the half, so a squared is equal to 72. Then the a will be the 9, 8, right? Is and is 3 is 12. 9, 8, 9, and 2 is 6, 6 root 2. Okay, so now we solve the A, right? Okay, so when we solve the A, then next is we're trying to solve the height. Okay, so the height is landing on the with connect QM, right? It's landing on the center of the equilateral triangle PQR, right? So now let's draw the height. So now we can see the height is the P, Q, and O, right? We know this one is A is the 6 root 2, and this one. So we know the QM is QO will be 2/3 of the QM is 2/3. The QM is root 3 over 2 of the side A. So that's why this is root 3 times A is 6 root 2 over root 3. Okay, so it's 6 root 2 over root 3. Then you can solve this, right? Okay, so 6 root 2 is a scale. So this is the 1, and 1 minus 3 is okay, so this is the root 2, 3, then 6 root 2, right? So this is the height. Then you can solve the volume is equal to the 1/3 of the base is root 3 over 4 times the a square is 6 root 2 square, then times the root 2, 3, 6 root 2, right? Okay, so it's 1/3 of the root 3 and 4, and this is the 72. times the 12 over root 3. Then okay, so you can see 12 12 12 root, so 72. Okay, next. So the wireframe at this figure, you can see we have the three here we have three perpendicular lines. I mean three perpendicular, mutually perpendicular segment. We have A, D, B, C, right? So we have one quarter is here, one quarter arc here, and one quarter arc here. Okay, then we have all this quarter arc. Then also we know each of this is 3 centimeters. So okay. So a quarter circle with 3 centimeters is attached to each pair of the segment. Okay. So that means the center is here, right? The center for this one is here. The center for this one is here. Okay, this is the PQR. Okay, that's the center. So we want to have a sphere, right? This is the frame, and we can have a sphere can snug into this point, right? That means when the sphere goes to here, the sphere cutting by this face and by this face and by this face, there will be always a quarter circle, right? Like this is the cutting line. So what kind of what is the radius of the sphere? If you can see this, right, means you can see we need a point. Okay, the point, the sphere, the center must be on the level of the P and the Q, right? Because I mean you need to be a quarter circle at A, right? So you must have the dA must be the same as the sphere of the height, right? So now you can see is if you extend this, this one will be the center of the sphere, because the center of the sphere must also satisfy the OA equals the OC and also equals the OB. Okay, let me use another color. So let's prove OA equals OB equals OC, right? So this you can see it's very obvious, right? You have the 3 of this, you have 3 here, right? It's a cube, so that's 3 and 3. So now your radius is 3 root 2. Next. So one cone of the radius of the 4 and the height of the 12, and another cone has radius of 8. And okay, let's draw. This is the center. Okay, let's draw the cutting face. Okay, along the center axis. So now we have this one is 12. The radius is 4, and the radius of 6, 6, and 4 here, right? So this is the radius of the intersection surface, right? That's a circle. Okay. Now, in order to, you can see we will have a cone here, and we will have a cone here, right? So as long as we solve the radius, we solve everything. Okay, so now let's see, this is the y, and this is the 12 minus y. Okay, now we by the similar triangles, okay, we have the 12 minus y over the 12. Let's see, this radius is this diameter is x, okay, equals to, as this radius is x, okay, equals to x over 6, and the other one is y over 12 is equal to x over 4. Okay, let me highlight these triangles. Okay, so you can see this triangle is similar to this big triangle, right? So that's why half of the diameter is x, right? X over this 6 is equal to 12 minus y over the 12. Okay, so the other similar triangle is this one. Okay, is similar to this big triangle. Okay, that's why you have the y over the 12 is equal to the x over the 4. So now you can solve the equation 1 and 2. Okay, after you solve the equation, you can have the x equals 12 over 5 and y equals the 24 over 5. Okay, now we can solve the volume, right? We have one cone and the other cone, right? They share the same base, so v is equal to v1 plus v2. The v1 is 1/3 pi of the 512 the square, right? Then times the height of the y, and the other one is 1/3 then pi 12 over 5 square times 12 minus y, right? So these are common term, right? So the final result will be 1 over 3 the pi then 12 over 5 square then times 12. Okay, you can go calculating to get the 576 over the 25 pi. So this one is the intetrahedron ABCD. Let V be the volume of the tetrahedron and R be the radius of the sphere that is tangent to all four faces of the tetrahedron. Okay, so here is the tetrahedron ABCD. If we have a center of the O, right, that means this one to the four face has the same distance of the R, right? Each one is R. Then we can in order to not to make it too messy, okay, let's only connect one of them. Okay, so we have the face, right, of the, for example, we have the face ABC, the area may be K1, the ACD is K2, the ABD is K3, the BCD is K4, right? So what you can see is we want to prove the radius is related with the volume, right? So our total volume will be the VO of the BCD plus the VO of the ABC plus the VO of the ACD plus the VO of the ABD, right? So this one is the 1/3 of the surface of the K1 times R, the similar thing, right? Plus 1/3 of the K4 times R. So that's why you can see the 3V over K1 plus K2 plus K3 plus K4 is equal to R. Okay. That's the A part. The second part. So we have the xy equal yz equals the zx equals 9, right? And we have the other one is equals 18. We want to find the sphere of the radius that inscribed. Okay, so now we know we have a pyramid of the A, B, C, D, right? And we have its 18, 18, 9, 9, 9, 9, and 18. So we want to find the center of the sphere, right? So in this case, you can see, okay, so this one is all isosceles triangle, congruent, right? And still the center should be land on here is the O, right? Okay. So now we want to find the radius of this one, right? So now we can calculating the volume, right? Use the 3 over the volume and divided by K1 plus K2 plus K3 plus K4, right? So we have the K2, K3, K4 on the surrounding on this side, except the base, right? They are all equal, so equals R. Now when we can, in this case, we can solve R. Okay. Now let's solve the. Let me. This part is A. This part is B. Okay. So now we can try to solve it. Okay. Let's draw this one. Okay. So let's see what's the, because we want to see what is the height. Okay. Let's calculate the height. So the height will be, we have a equilateral of the BCD. Then here is the center landing on the middle, right? Landing on the centroid point. So that's why it's 9, 9, 9. And then it's the 2 root 3 times 9, right? It's 2 root 3 times 9. And the BO is the 2/3 of this, right? Is 3 root 3. So BO is 3 root 3. Okay. If BO is 3 root 3, then you can see we have the A and the O and the B is 18. Then we have the 3 root 3. Now what is the height? The height is 3 root 33. Okay, once you know the height, right, you can calculate the volume. So the volume will be 1/3 of the root 3 over 4, then times the 9 square, right, and then times the 3 root 33. Okay, so you can, after reduce, it's 243 over 4, then root 11. This is a part of the result we need to use. And the other one, we need to calculate in one of the side surface, right? So we have 18 and 18. We have 9 over 2 and 9 over 2. Now we can calculate in the side of surface. Let's calculate in this hx. The hx is equal to what? 9 root 15 over 2. Now we can calculate in the surface, side surface, right? Maybe let's say it's K2 equals K3 equals K4. Then it will be equal the 1/3 of the 9 times 9, 15. So that's why it is 481, 15. Okay, now we can calculate in the K1 plus 3K2. It's equal to the root 3 over 4 times the 81 plus the 481 root 15. Okay, so it is equal to 4 root 81 then of the 3 times this, and 3 root I'm sorry, 3 times this. So 3 root 15 plus the root 3. Okay. So after you have this, and you have the volume, right? This is the volume, and this is the k. This is the sum of the k, sigma k, right? And then you can calculate in the radius of the inscribed sphere will be the 3v over the sigma k. Okay, you finally, once you get into that, will be the 3 root 11 44, then 3 root 15 minus root 3. Okay. Okay, so let's find the formula for the total surface area of a right circular first term with the base of, okay, we want to find the surface area. It's the same thing, so you can see the first term is always cutting by the we extending this is a cone, and we cutting with a small cone, right? Then with the rest of this, so this is the L, and this is a small cone, this is a big cone. The radius is R1 and R2, so we know this side is the, so we know for this side is x, so we know x over L is equal to the R1 over R2 minus R1. So we know the x is equal to the R1 and R2 minus R1L. Okay, this is R1, R2 minus R1L. Okay, so the total of this length is the R2 R2 minus R1L. Okay, this we need to use this. So it's easy to solve the two surface here, right? So it's simple. So this one will be the pi R1 square plus the pi R2 square is the sum of the base. Okay, now we want to see what's the side, right? The side surface. When we know the expanding of this one will be this is the P. Let's see, it's a A. This is the B. Okay, so P of the A to the A prime, and B to the B prime. Then this is the length is L. Okay, so let's see the arc length, right? So the arc length, this is the R1 over R2 minus R1L, and this one is the R2 over R2 minus R1L, right? So the length of this is the 2 pi times R1. The length of this is 2 pi times R2, right? So the area of a segment, okay, is the area of a sector is the arc is 2 pi R1, okay, times the radius, okay. So the radius here is R1 over R2 minus R1L. Okay, so this is the sector 1. Then we have the big sector 2, right? Sector 1 and S sector 2 is equal to 2 pi R2 times the R2 over R2 minus R1L. Then what we see is the difference, right? We want to calculate the difference between the two. That's this one. This is the side surface we really need, right? So S side surface is equal to the 2 pi L, okay? Then the R2 minus R1, we have the R2 square minus R1 square is equal to the 2 pi L then R2 plus R1. Okay, then the total surface is equal to the S of the sigma base plus S of the side. So it's pi R1 square plus R2 square plus 2 pi L, then R1 plus R2. Okay. So the final one, so a ball of the radius is is in the corner of the room, okay, and the tangent to the two walls, and so this is the side and the floor and the wall, okay. So we have two walls and this. So you can see I have a center of the O, right? So the center of the O is here, here, and here, right? So they touch it. So that's why it's 1, 1, 1, right? Okay. And it's 1, 1, 1, so there is a certain spacing here, right? Because this the distance will be the root 3, right? It's square root of the 1 square plus 1 square plus 1 square is root 3. Okay, we already did this in the previous chapter. Then you see there is a spacing here, and what we want to do is a small ball is also in the corner, right? And it's also tangent to both walls and the floors. So there is a small ball. Let's see, there is a center is P, okay? Then we know it is this is also touch all the three faces, right? So the question is asking you what the radius of the small ball, right? So we know the radius of the big ball and the small ball. The big ball is 1, right? The small ball is R, right? Okay, then the rest of them is the root 3 minus R, then minus 1, right? That's this point A. Okay, so we know. Let me draw it clearly for you, okay? So AO is root 3, right? Then you know there is a point P, right? So the radius of the big ball is 1, right? Here is a 1, here the R, right? Then so they together is root 3, right? So this is the root 3 minus 1 minus R. Okay, now we want to see what's the radius of the small ball, right? Okay, so think about it. The radius of this segment, right, is also we can calculate based on this based on these 3 r's, right? It's a cube. So the root 3 minus 1 minus r is also equal to the root 3r, right? So now you can solve this equation. So r is equal to, which is equal to, yes, okay. So that's it for the challenge problem of this chapter. Thank you, bye.